Okay, Assalamu alaikum everyone. Hope you guys are able to hear me fine. If you are, then please, maybe one or two folks just raise their hands so I would know.
Yeah, I can hear you.
Okay, perfect, perfect.
Yeah, I can.
All right, sounds great. Um, I'm gonna show that again. That this is the scholarship program for at this time, which is IEC Hussaini is currently offering. There are three major categories: middle school seniors, high school seniors, and college undergrads. That covers freshmen through senior years. The registration deadline is May 31st. You have about 3 months. Um, it's an extensive form, about 12 pages long. So we are asking for as much information as possible we could get. It is 100% merit based. So we're trying to pull or get as much information, from the candidates as possible to make an informed decision. The form is live on our IEC Hussaini website, which is iechussaini.org. And you can reach out to me maybe after this class or during this time, or because I'm the one who's spearheading this effort. So if you have any questions or concerns or comments, feel free to reach out to me. You have my contact details. All right. Come on, mouse. Okay. All right. So today is a very loaded session since we missed the class last week. Um, on our Saturday session, there were only three folks came in, and so we had to cancel the class because we don't want to duplicate our efforts on that. Excuse me. Um, so we are going to cover the critical pieces today, and if you guys are okay with that, we can conduct our last class. Our last class was supposed to be on March 25th, but I find out that actually my parents are flying back to Pakistan, so their flight timings are pretty much the same, around the same class. So what I was thinking for our last class, if you guys, excuse me, if you guys are okay with that, we can conduct our last class on this coming Saturday, which is March 20th, about around the same time, and we'll conclude our, this training session. So in our last class, we will do our, conduct our labs plus, the additional or the advanced items, which I talked about, at the start of this session. So if you guys okay with that, just let me know either in the chat or unmute yourself, and I'll just send the invite for this coming Saturday. Everybody's so quiet right now. Looks like do I take it as a yes? Okay.
Yes, from me, Ali Nakwi, Shabar Nakwi.
I'm sorry, what? Can you repeat again? I couldn't hear you clearly.
That's why I say yes from Shabar Nakwi.
Okay, Shabir, right. Thank you. Okay. So I have confirmation from only two folks. If that day doesn't work for you guys, uh, what other day do you guys suggest?
Oh, what was the day that you had proposed?
Saturday, March 20th, which is 2 days from now.
Yeah, that's fine.
Okay. Okay. Perfect.
Same time, right?
Yes, same time. It will be 7 to 9 p.m. Chicago time.
Okay.
Okay. All right. So I'll send you guys, a updated meeting invite. So keep an eye out on your emails, for that lecture, for our Saturday's lecture. All right, so let's get started. So today we're going to be covering AWS database services, and also we're going to be covering extensively AWS networking services. These two are, one of those critical ones, not just only required for your job function, but also for, from the certification standpoint as well. Okay, so in the database services, we're going to be covering relational databases, what are those, and non-relational databases. And also, I know in the networking side, we're going to go deep dive into, we're going to start off with the network overview. We're going to look into the subnetting, how the subnets are formed, how do we create subnets, and then routing, how does the routing works, the VPC, which is the virtual private cloud, which is the external or the outer boundary of your AWS account. And then we're gonna look into Route 53, which is Amazon's DNS service. And we're gonna look into how the DNS works. And then ELB, which is Elastic Load Balancers. How does load balancing works, and on what layers do we put load balancers, and what type of load balancers Amazon offers currently. And then we're going to look into the auto scaling, like how do we scale out and scale in automatically, without doing any manual intervention work when our workloads increase or workload decreases. So we're going to look into that. All right, so the traditional database types, they are normally called SQL or SQL databases, which is, these are the structured databases. They have a certain structure. They have tables and rows and columns, and some additional values there as well, like the keys or the indexes, views, and arrays and nested tables and all that. But the key area is, give me 1 second, let me get the pen. The key demarcation line for the SQL databases is, these areas. They have the table that comprises of rows and columns. The data sits there in a structured format, and if I may just get to the so in a traditional database, so we have a table, and that table has certain columns. Let's say, this is, let's say, a date column, and then let's say first name, last name, let's say your phone number, your street address, and let's say the last one is your say this is your state. Okay, so top down ones are the columns, and left right, from left to right, they are called the rows. Each row is a complete set of it's a complete data set. It's a complete set of data which resides in. Let's say if I fill in my information in here, let's say I put in, let's say this is record number 1. So this record number 1 will have, the date in it, my first name, my last name, my phone number, my street address, and my state information. And then, record number 2 will have the similar information, and, go down, and, up to record number N will have the similar information like similar in the sense that, date will have, dates in it, and then, the phone number column will have, phone number information in it. So in the row, from if I look at from the, left to right or from the, row standpoint, this record number one will have a complete record of one single individual, and that will have, whatever the, fields we have in the table, the data, sorry, the date, the first name, last name, and, whatever and whatnot. So um, left to right rows will have, a complete set of, record in it. But on the contrary, from top to bottom, the column view, column will have, information about that specific field. Let's say, this first name field will have first name for all the records. Let's say the first one is the Faisal, let's say other one is Ali, someone else, someone else. So if I look from the top down view, I will see only the that specific the column and the related fields that are filled into it. But if I look at from the left to right, this will give me an individual person's entire data or entire information there. So this is on a gist or from a very high level, this is how the structured database work. Structured databases, they have, a certain structure here, and every field, has to be filled in, with certain value. Um, if we go in there to the into the non-structured databases um, or NoSQL, what do they have here is they have tables, similar tables, and then they have the items and they have the attributes. How does the NoSQL or not only SQL or unstructured databases, how do they work is on contrary to this, let's say we have a table which is a NoSQL table. So it does not have to have the exact number of columns or exact number of rows like we have here in this example. It will be different than this. So let's say we fill in the information. Let's say we fill in first record that let's say the first record was which is from the row standpoint. Let's say we are filling in certain records in here. So let's say first record will has only the date and the last name. That's what we filled into it. The next one is it has only the first name and the phone number, let's say. And then the third record, it has date and last name and the first name. So you see that if you look at it from very top, um, the values that are being stored in it, they are not stored in a certain order like we have here, that values are stored, the date and then the first name, last name, it goes one after another. But here in NoSQL, we have the leverage to define our table structure for each single row. For each single row, let's say I do not need the rest of the information what we have in here. All I need is just the last name of the person and whatever the date that person registered in, for example. So for that for this record we have only two fields in here. But let's say this third record we have three fields. Maybe the fourth record, it has only one field, or let's say the record X, we have, let's say you know say 20 fields in here. So here in the NoSQL, we have uh, the leverage that we can, increase or decrease the number of, columns according to our needs. So we do not have to, follow the actual structured method what these structured databases, give us. There are some, leverages on it, and companies are, currently aggressively or actively using this NoSQL, where they do not have to maintain the full-blown table structure or full-blown database, where they may be just filling in, let's say, two fields or maybe 10 fields, or every row has a different field structure. So this gives us the liberty to the organization that, hey, you know what, I do not have to maintain a full-blown military style structure. I just have to go whatever I like, and whatever I want, I'll just put that in there. Whatever is not required, I'll just yank it out of it, or do not even fill that information. The rest of the information is, pretty much the same, the primary keys and, the indexes and all that. This is, pretty much common there. Um, the How the NoSQL works is, this is a field and it has an attribute in it. So let's say the field name is, let's say, date, and then attribute is, let's say, today's date. Field name is last name, and then attribute is, let's say, Abbas in my case, or whatever the case may be. So instead of calling it a value, or calling it you know a specific record, they call it attributes. So this is the main demarcation line between the two common database types we currently have. SQL databases, very common example is Oracle. Very common example is Microsoft SQL Server, or PostgreSQL, or MySQL. These are very common SQL, or the structured database types. On the NoSQL side, there are several which are very common these days. DynamoDB is one example, and we're gonna see more examples, as we proceed along. Um, Going back to the moving on to the next one, which is the database overview. This is the overview of AWS database services. So AWS offers different type of database services for us. The From 20,000 feet, what I see is there are two major demarcations. One is the SQL databases, and another one is the NoSQL databases. Amazon SQL databases, or database engines, Amazon calls them RDS. RDS stands for Relational Database Service, because these are the relational models. This area here, this is the relational model here, that each field has a relation with another field, or uh, each record has a relation with with each other. So this is a relational model, or the structured model. So Amazon offers these services under the umbrella of Amazon RDS. Along with that, on the NoSQL side, Amazon offers DynamoDB, which is a key value store. Like, there is a key, let's say key is last name and the value is Abbas. Key is first name, value is Faisal, as an example. So it's a key value pair database, which is the NoSQL type. And then the third type Amazon offers is the Amazon Redshift, which is the data warehouse services. Um, Data warehouse, 20,000 feet overview is, it's a database of databases. Let's say you have, like, data coming in from different areas. Let's say marketing is generating some data, your plant is generating some data, or some industrial processes data, generating some data. So they all, all the data, it's going into one warehouse or data warehouse, where the entire, whatever the organization structure is, the entire organization is generating data, and it is being dumped into this big warehouse. And from that warehouse, mostly it is used for the analytics purpose. So that let's say they want to create some dashboard or some analytics out of it, that let's say how many uh, let's say let's take an example of an industrial process. So let's say how much of a raw material is used, how much time each machine is taking, how much waste of raw material, we are seeing. So, these type of, information that gives some, insights out of that data. That's what, the data analytics, works in, or comes in picture. So that's where, you use the data warehouse capabilities. And then there is another one, which is Amazon calls it Elasticache. It is in-memory database. So what happens is, let's say you have, let me just quickly create one. Um, let's say you have a machine and you are, if you remember, there were EBS volumes. That's what we use for operating system and databases. And inside that EBS volume, you have the database running. But there is a certain limitation of this EBS volume or the regular disk storage. So in order to get over with that, the speed factor of your storage, um, Amazon, and actually, not just Amazon, but there are several other service providers. So what they offer is they offer the in-memory databases. So databases, instead of residing on a disk, they reside on the RAM of your machine, because RAM is the fastest part, inside the entire computer. So instead of having them residing on the EBS, which is kind of a bottleneck for organizations that, let's say, they are processing, let's say, millions of transactions per second or millions of transactions per minute, for example. So that EBS may be a bottleneck factor for them, so they opt for in-memory databases. Those databases, they reside specifically in the RAM. And these machines, they are pretty hefty machines when it comes to the RAM. It could be like 1 terabyte size memory, or maybe 20 terabyte size memory, where the entire database is residing in, and getting it processed. So the Elasticache, which is the in-memory key value store, which is the same as key value store here as well. So this is another type of uh, no SQL services. So these three are the, actually, no, I'm sorry, let me take it. So this one and this one are the NoSQL services, and this one is SQL, and this is also an SQL service. So these are some of the services Amazon offers. Okay, moving on. Amazon, there's some additional information about that. You can, once you get the slide deck, you can go into the Amazon products and look into those database services. Let's say you are doing some research for your organization or for your personal testing purposes or learning purposes. So there are some use cases for those. Let's say you have a relational database. So mostly the common use case is the traditional application, or your ERP or your CRM, or any other application that you're running, and this is the database which is running underneath it. So these are some of the use cases here. And for those, Amazon has, inside the Amazon RDS, there are Amazon Aurora, Amazon Redshift, or these are some of the Amazon services or database services that you could look into. I'm not gonna drain the entire slide. I'll just pick a couple more examples here. Let's say you have a huge ledger running, or let's say you are going into the blockchaining. um, there are some of the use cases for the ledger databases. Amazon calls it QLDB. They have the graph databases, which is mainly used for fraud detection, and other use cases are social networking or some recommendation engines as well. um, because they are pretty huge in size, so most of the time they are being used for these use cases where you use a bigger data set to to connect the dots, or to get the insight or the intelligence out of it. So for that, Amazon, offers a service called Neptune or Amazon Neptune service, which is a graph database service. Then there are some in-memory database types as I we just discussed that. Plus the document DB, which is mostly the no SQL offering, and document DB is one of that that has the capability with the MongoDB. Okay. Um, all right. So as I discussed, the from the 20,000 feet overview, if I look into it, like there are two major demarcations. One is the relational database, and another is the non-relational. Amazon relational databases, Amazon calls it RDS, and also there is another service which is called Redshift, which is mainly used for the data warehousing. So if I put some boxes around that, so Amazon RDS covers this, Redshift covers this, and then they have the DynamoDB in memory, and then the Neptunes, right? They are actually part of it. Okay, so inside the relational, you have two major ones, Amazon RDS and Redshift. RDS is mainly for your regular database work that has further demarcations. Amazon came up with their own database as well. They call it Amazon Aurora. Um, and then they have commercial databases and community databases as well. Um, and some of the use cases are MySQL, Postgres, Microsoft SQL Server, or MySQL Server in the community edition, or MySQL Server commercial edition, Oracle databases, or PostgreSQL. You must have heard these databases, at least one database name. You must have heard, because these are very common names there. On the warehousing side, Amazon does not offer any other commercial or community one. Amazon offers only its own data warehouse services, which is Amazon Redshift. On the non-relational side, they have the DynamoDB, they have the Elasticache, and the Neptune. So these are some of the common ones, and their names there. Along with that, Amazon also offers the database migration service. What it does is it helps you migrate your on-prem database from from your on-premise into AWS cloud. So let's say you have, for example, 20 terabytes of data, and you have a very complex structured database that is currently running in your database, or sorry, in your data center. So one option is to zip all those files, compress it, and then send it over the wire or through Amazon Snowball services, and then send it to Amazon cloud, and then have it run there. Another option is Amazon with this database migration services. So you have to connect your on-premise database with the migration service, and then migration service takes over your schemas and data and everything, and then have it migrate over into your database into the cloud. So it's kind of a seamless service, helps out in a migration of complex databases. Okay, I'm not gonna drain this slide. This is mostly about what are your needs and what consideration Amazon offers for you to consider what type of database you want to consider. Um, let's say you have a fully managed MySQL or Postgres database running, and you want, or you want to create that into the cloud. Amazon says that go with Aurora services. Let's say you have a serverless or no SQL database requirement. Amazon says why not explore the DynamoDB services, and so on and so forth. Okay, this is the same thing, this is the continuation of the previous slide. Okay, I'm gonna stop it here for any questions that you may have before we proceed on to this bigger section. I hope you guys are able to hear me fine. Okay. Okay. All right. All right. Let's move on then. Let's start with AWS networking services. This is kind of a bigger section, and normally I cover it in two classes. I'll see, I mean, how far can we go on this class? Otherwise, we'll just spill over to our to our Saturday's class to continue on this. Okay, so the networking services, we're gonna look into the overview, subnetting, routing, VPC, and these services here. All right, so let's start off with that. Um, so IP address types, if you remember, we looked into the IP addressing. There were two type of IP addresses, IPv4 and IPv6. We looked at very top level. IPv4 was the dotted notation, and IPv6 was, the hexadecimal notation separated by colons here. Um, So that's the very top overview. For the exam standpoint, you do not have to remember this all, but let's say if you have interest in networking, or if you are going into if you're going to a job that requires you to have networking skills or the sysadmin work, then this will be kind of an important area for you. But from the foundation certification standpoint, you probably would not need to know, this much of a detail, but it's good to, learn and understand how networking works because let's say if you go for the solutions architect associate exam, they do not normally, give me 1 second. Okay, so so for the solutions architect associate, you will not be questioned on the networking section, but there are certain services that require you to understand the subnets and all that. So for that, yeah, you you have to have some basic understanding on the networking area. Um, there are two major demarcations, IP version 4 and version 6. IP version 4 was 32 bits in size. V6 is 128-bit in size, about 3 times the size of each packet or the address. And then it gives you the number of addresses, 2 to the power of 32. That gives you 4.2 million um, IP addresses you could create from the IPv4s. IPv6, you do the math, if you do 2 to the power of 128, and like it's gonna go over trillion usable IP addresses. Addressing format, as we discussed, it's for IPv4 it's a dotted notation. IPv6 is a hexadecimal notation, and that's the major demarcation among the two. IPv4, when we started on IPv4, back in the days, they find out, or um, they suspected that IPv4 is going to get consumed pretty fast, and then we will not have available IP addresses to connect all our devices. So back then, the IPv6, came into being, and right now, pretty much, the way things are currently moving, like with the advent of the IoT devices, that every device gets connected to the network, and every device gets the the IP address. If you go with IPv4, we probably will not be able to get that accommodated. So IPv6 is one example. Now the service providers, like internet service providers to your home, they have switched over, or they are in a process of switching over to IPv6, and same is the case with like your cell phones. The data that you connect to your cell phones, it's mainly being kind of communicated through the IPv6. Okay. Um, there are um, although there are 5 different classes of IP addresses or IPv4 addresses, we're gonna continue on IPv4 for a while on this here. I'm not gonna go much detail on v6 for you guys because it will confuse you guys. IPv4 has total of 5 classes, but out of which 3 classes are in a common use. Class A, the address range starts from 1 through 126. Class B is 128 through 191, and Class C is 192 through 223. And then we have Class D. They are for multicast addressing, and Class E is reserved. And how the classes are defined. Again, coming back here, IP addresses, if you remember, they are dotted notation. So between each dot, this is called the dotted. This is called the segment of each class or each IPv4 address. Okay, so between the two, there is a dot. So let's say if I have an IP address, let's say 10.20.5.10, for example. So if I have this IP address, let's say in class A, the first byte, which is the first octet here, this actually tells me the network ID. And then the remainder tells me the host ID. Okay, what it is. So network ID is like this is the network, and host ID means that this many hosts I can have within that network. Let's say, and I'm gonna come. I think in one of the slides, we have that detail that how many hosts can I have, in each specific class if I have it like subnetted or if I do not have it subnetted. So just for your understanding, in class A, the first byte is the network byte, or the first area before the dot is the network area, and then the rest, like the other 3 bytes. So let's say if this is the class A address, the first will be the network, and the remainder 3 will define the host, like how many hosts I can have. In class B, it actually gets split into first and the second, and then third and the fourth are the hosts. So for class B, you have 2 bytes for the network, and then the remainder 2 are for the host section. In class C is a reverse of class A, where we have 3 bytes or the 3 octets for the network section, and then the remainder, the last octet is for the host section. If I come in here, these are pretty much the same. So if I come in here, you see that the first one is the network, and then the remainder 3 are the hosts. Class B, network, network, host, host. Class C is network, 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 and host. Okay. If I see that class A, it tells class A the first octet. Class B, this information is the first, second octet. Or let me just clean it up real quick. Okay. So here in class A, this is the first octet. Class B, this is the first octet. Class C, this is the first octet. Okay. Let's say if I have an address starting from 1, or it goes up to 126 in the first octet here, that means it's a class A network. So this IP address which I put in here, 10.20.5.10. So if I look at the first octet, it is telling me this is a class A network because it falls under this. Class B, 128 through 191. and then class C is 192 up to 223. You guys must have seen a very common example is normally use 192.168 dot, let's say 1.100, for example. So these two, it's very common, at home and also in organizations as well. Um, so these are the reserved ones, and I'm going to come to it in a bit. So the first section for class A, the first octet is network, the three are the host. Class B is 50-50, half network, half host. In class C, three network and one host. That's the major demarcations, in those. Um, Not for the exam standpoint, but maybe for job standpoint, you might want to remember what falls under class A 1 through 126, class B 120 to 191, and class C 192 up to 223. Okay. All right, I'm gonna come to this example in a bit. Right, so there are two major types of IP addresses, either IPv6 or IPv4, whatever the type may be. They are called the routable versus the non-routable IP address, or reserved versus non-reserved IP addresses. Non-routable IP addresses are those, let me just go back to a drawing board in here for you guys. All right, so let's say I am in an organization. Let's say this is my organization boundary. I have different servers. Let's say I have it here. For example, this is an on-prem, setup for, just take as an example. Okay. So these computers, they are connected to some switches or routers. Okay, and then let's say, these two routers are connected to each other as well. So they all are connected to each other. So whatever the communication, let's say this is the, for example, this is the marketing department. This is, let's say, finance. And let's say this is, let's say this is my plant or manufacturing department. Okay, so they all are, interconnected. Let's say, marketing, machine A connects with machine B, through this network, or, they get connected to, let's say, plant machine, or finance is connecting to, any of the marketing machine or any of the, let's say, the plant machine. So they all these machines, they are interconnected. They are connected within that, within the organization boundary here, which I just draw, right? So whatever is happening within the inside the boundary, it doesn't have to go outside. Everything is, working internally. Those who are in the Microsoft collaboration suite class, that's where, you guys were, doing the SharePoint work, which is mainly used for internal communication or internal collaboration among the team members. So what happened is, if you guys remember, in one of the class, I talked about intranet and internet, right? So intranet is what is within the boundary. So each machine is assigned an IP address, right? Since these machines, they do not have to go outside, they will just talk to themselves internally and, get the work done, marketing reaching out to plant, or finance reaching out to plant, or marketing or whatever, and, vice versa. So everything, whatever the day is going, they, during the day business, they do not have to go outside. It's just, everything is happening, inside the boundary. So that boundary is called the intranet, where the traffic does not have to go outside. The traffic stays within the company. It does not have to go outside. That's the intranet. And that's where, since all the machines are connected to the network and they have an IP address assigned to them, so in these machines, we assign the non-routable IP addresses or the reserve IP addresses. Why do we assign non-routable IP addresses? Because for the non-routable IP addresses, we do not need any, we do not have to pay for those IP addresses. They are the local IP addresses required to communicate locally among these machines. So that's the key, intent of those, of these, non-routable IP addresses, that, they just stay within the boundary, and they do not have to, go outside. Let's say they have another department, for example, that is their, they have, some web servers, for example. These web servers, they are connected internally to the internal network as well, but they have to, publish, their, let's say, websites or web servers. They have some, web servers running, and they have to publish to the outside world, right? So whatever, the business they do. So these machines, they require an IP address. So we will configure one IP address for the internal communication, that is the non-routable IP address. And the another one, for example, we're going to configure for the external communication, and that IP address that will take them into the to the internet. And these IP addresses, which are configured for the outside public, for, let's say, for us, you and I, um, for that purpose, we configure the routable IP address that will not be taken from the non-routable, blocks, but it will be purchased by the, like, you purchase from the service provider, and that IP address will assign to it, so that it will be published to the, or used for the outside communication. So we purchase only, let's say, three public IP addresses, which are, for the public internet access, but the remainder we do not have to purchase, we just pick inside it, and we will get the work done. Coming back in here, so a routable IP address is one that can be reached by anyone on the internet. That's the routable. Remember, see this here in our case, we assign a routable IP address in here. This is used for the, internet connectivity, or for the outbound connectivity. A non-routable IP address, which people cannot reach from the outside world, it will stay within your organization. Like, marketing has, some servers, and let's say finance has some critical servers. You do not want their location or their data to be published to the outside world, so they will stay within the organization. That's where we use the non-routable IP addresses. Um, there are certain, reserved spaces for non-routable IP addresses. 192.168 is a very common one, which people use in their organizations, or, in their homes as well. And then, there are Class B reserve. They start with 172.16. Class A starts with, Class A reserve one are 10.00. That's the starting range of those. If you guys remember, Class A, first is the network. Class B, first two are the network, and Class C, first three are the network. And then the remainder three, remainder two, remainder one, they are the host ranges. That tells that how many hosts or how many servers can I, connect with them. Okay. Okay. Let me just go do this real quick. So if you look at this example in here, you see that, actually I have this net router here in this example. Forget about the net router. So, those machines, the example which I gave, the marketing machines, or, the finance machines, they are connected. They are on the same subnet. If you see that 192.168.1.3, if you see that, the commonality among all these, they all have 192.168.1. The first three octets are common among these, right? So since this is Class C, if you remember, you see that, first three are the network. So they all are on the same network, and then dot 3, dot 1, dot 2, dot 4, they are the host. or let's say the server IP address. Let's say let's say this is my laptop. This is, let's say, Imtiaz Bhai's laptop, or this is, let's say, Ali's laptop, or this is, let's say, OS's laptop. So or desktop, right? So they all are connected within the same network range. You see that the network range is same, 192.168.1. The host number is different. Host number has to be unique. Like dot one is here, dot two here, dot four here, dot three here. Let's say there's one more person came into the office, and they got, let's say, 192.168.1 dot, let's say, 200. They got, come on. Ah, okay. Did I get those? Can you still hear me? Looks like the machine got froze, I guess.
Yeah.
Okay. Okay. So let's say a new person came in, and he was given IP address .200. Since the person will have the same network range, that person will be able, or that machine will be able to communicate over this network, and they all will be communicating to each other. One common theme is they all, within a network, all the machines have to be within the same network range to talk to each other. Let's say there's one block and machines are sitting there, and there's another block. That's where the routing comes into the picture. There's the internal routing, there's external routing. With the internal routing, you can have two subnets connected to each other, and let's this department talking to this department, or let's say this department gets filled up and they need more IP addresses, so they created another block which is the extension of this block, and they get connected through the routing, and they will be able to talk to each other. Okay, I'm gonna come to this network address translation in a bit. All right, so next one is the there is a CIDR notation, classless inter-domain routing. It is defined with slashes. Let's say I have IP address 10.20. Let's say I have a subnet 10.20.100.99/16. Okay, so what does this slash means? And slash, and what does this number after the slash means? What does it mean is slash tells me that how many hosts. Is there a question, Wesbhai?
No, this is called subnet.
Yes, I'm coming to it. So so the CIDR notation, it tells me, the slash number, it tells me that how many hosts, or how many, let's say, laptops, or how many workstations, or how many servers can I have within that subnet, or within that specific subnet, what I have here. So let's say if I pick /16, if I go in here, /16 tells me that I can have 65,000 servers or 65,000 hosts within that subnet. Let's say my CIDR is, let's say, /28. So it tells me that I can have only 16 hosts within that specific subnet. So this helps me define the subnet boundary. Let's say I bought one bigger subnet. Let's say I bought one bigger subnet, sorry. And this bigger subnet was, for example, 10.0.0.0, let's say, /16. Okay. Now, because of the security reasons, my network architect told me, hey, you know what? We need to segregate duties. We need to have a separate subnet for marketing, a separate subnet for, let's say, engineering, a separate for IT, a separate for our plant, and let's say a separate for our finance. So he asked me to carve out this big block that we have into these 5 different subnets. Let's say he asked me, hey, you know what? We currently have, let's say, 20 people in the marketing department, but marketing is expecting a growth in their department, and by the end of this year, it is going to be 40, from 20 to 40. Finance, let's say he says that, you know what, they are not expecting any growth in finance. They currently have, let's say, 30 people, or sorry, let's say 36 people, and they will stay within that boundary. IT said that, you know, they have only 10 people, so let's just, you know, stay within that range. And, you know, let's say plant, you know, similar thing, let's say, you know, only 5 people, no growth. Um, let's say, you know, some XYZ department, you know, it has only, you know, 2 people, but they are critical. So we, you know, we need to have, you know, have an IP address, you know, carved out for them. Now that this is a bigger block, how do I know this is a bigger block? Because it's a 10 dot, so it's a class A network. So again, going back to this, going back to our previous conversation, class A, how does it defines? The first octet is the network octet, and the other 3 octets are host octets, right? So I can have more number of hosts, less number of network. And this is what I'm seeing that, hey, you know what, I can have more number of hosts in here. Since this is /16, so if I'm gonna just simply go into the table here, but there are several online tools available. You do not have to, we used to do that like manually and find, and the frequently you do that, you know, you will remember, hey, you know what, /26 gives me 64, or /21 gives me 2K, or, so on and so forth. The more you are in practice, the more you learn, or more you remember that how many number of hosts, you know, can I have in that, right? So let's say so this one is /16. This gives me that I can have 65,000 hosts. Okay. And I can have 256 subnets. So I can carve out 256 subnets out of this one. I do not have to carve out all like 256. What I can do is, you know, looking at my current demand, I can just carve out 1, 2, 3, 4, 5. I'll just carve out 5 subnets, and the remainder I'm gonna just leave it there. Okay, I'm gonna leave it unused because there may be more departments coming in, or there may be more machines coming in, and then, you know, we will be just, you know, carving out more and, use, you know, from this subnet or from the unused block. So marketing department currently 20, but the growth is 40. So I'm gonna keep an eye on the number 40 here, and let's see where can I get number of hosts, in the range of 40. So minimum range is 32, maximum is 64. So I cannot pick 32. I'm gonna pick 64. Okay, and I cannot have two 32s. You know, why carve out, you know, smaller chunks? If I can have a bigger chunk, I'll just use that. So the first subnet I'm gonna carve out, with /26, uh, 10.0.0, whatever the number may be, /26 will be the marketing subnet. And then for the finance, you know, they need 36. The minimum, you know, ceiling limit is 32, so I'm gonna again go with 64. So I'll just go with 64, sorry, with /26 for finance. Same goes with, I'm gonna look into, the other numbers here, and I'll just, pick one for these. And then with this big subnet of 10.0.0.16, I have carved out, different sizes, and, assign it to, those different departments, and, they can have their, machines connected in here. Okay. So whatever I just told you, these are very, some of the tools which are currently available on the internet. You can just simply go in there, put in your subnet information, put in your number of subnets you wanted to carve out, and, it will just, give you the entire information from that for you. Okay, VPC number 18. Okay, before I come to VPC. Okay. Let's do one thing. Let's take a 5-minute break, and then we'll continue on on this VPC overview. Okay. CIDR stands for Sayyid Ali. It's CIDR is as inter domain. Commonly called slash notation, like /16 or /24. Okay. Right. So let me just hit the timer here for you guys. Take a 5-minute break. We'll reconvene in here. I'll be back. Okay. Sorry, was talking on mute. Any questions so far?
There is a very interesting question in the chat.
Let me see. Class A, Class B. Yes, Class C. Sorry, this 127 is mainly reserved for. It's not mainly used. It is mainly used for local hosts or like within that specific host. Say as an example, let me just go in there. Where's the whiteboard? So let's say this is my server. Let's say my Linux machine. Okay. So there is an IPv4 I assign manually to it, but there is one IP address assigned to it soon as I have the TCP IP running on it, and that IP address is from the 127 range. This is called local host IP address, and that is mainly used for internal to this Linux or to this Windows machine. And we do not even this is not routed to the outside of this machine, like it stays within the boundary. Let's say this is part of this, let's say this Linux machine, for example, is part of this here. And actually every machine will have that 127 IP address range, so that is not used outside the specific host boundary. Okay. Okay. All right. Let's just go back in here. So AWS VPC. VPC, as we say, this is the outer boundary of our AWS account. VPC stands for Virtual Private Cloud, and every account has at least one VPC in each specific region. Let's say I logged into the console right now. I will see one VPC in the Virginia region. And then, if I go into, let's say, Singapore, I will see another VPC there. So there's, a default VPC Amazon creates for you. That is the boundary of my, AWS account. So what we normally go, and how the hierarchy works is you have the AWS account, and then underneath it you have the VPC, then you have subnets, and then you have your EC2 instances, and then you have your applications running on top of those EC2 instances, right? So inside in the VPC there are a couple other components there. So this is my VPC boundary that you are seeing, and if I expand on this diagram here for you guys. So you see that this VPC has a subnet block 10.0.0.0/16, which is the IPv4, and there's IPv6 subnet as well. We're not going into the IPv6 at this time. So IPv4 has like this is a bigger block that is assigned to this VPC 10.0.0.16, and with this VPC, what in this example, what they have done is they created two subnet groups, and what these two subnet group are, they are come on, where is it? Okay, so the first subnet is they created a /24, and the second as well they created /24. If I go back in here, /24, if you see that each /24 will have 256 hosts in it. So if I go back in here, so with this subnet, what we are seeing here is we have 256 number of servers or EC2 instances I can have in here. Similar number I can have in here as well. Since this is class A, so if you remember, class A, the first 10.0.0.0/16 class A, so the first is a network, the other three are the hosts. So what they did is they carved it out, this /16, if I go back in here, /16, if you remember, it can have 65,000 number of hosts. So I can have total of 65535 number of hosts in here, and they carved out with subnet 1 and subnet 2. Subnet 1 is 10.0.0.0/24, and the second one is 10.0.1.0/24. So each one of them will have 256 each. Okay, now this is 256. This is a classical example here. Let me just go back in here. Where is my whiteboard? Come on, machine, what's happening? Why is it choking on me? Okay. All right, so let's say this is /24 subnet. According to the CIDR notation, I can have 256 usable hosts or usable IP addresses. Come on. Was it? Are you guys still able to hear me?
Yeah.
All right, perfect. Okay, yeah, my machine is acting weird. I don't know why. Anyways, so in a classical network example, we can have we we cannot have the entire 256 number of hosts to be used. Okay, what it does is please cooperate, machine. Okay. So out of this 256, in a classical example, or sorry, in a classical network subnetting, the first two IP addresses of this, let's say, there are a total of 256. The first two are reserved. Okay, the last one is mainly reserved for broadcast, and the first one is mainly reserved for the network boundary. So out of those 256, we can use 254 IP addresses. Okay, This is a classical network example. Okay, like outside the cloud, if you have to carve out within your, let's say, data center, then you will be able to use only 254 hosts out of this 256 range. But inside the cloud, what Amazon does is I'm gonna show it to you guys. Come on in here. Yes, subnet reserved IP. So what AWS does is AWS actually reserve 5 IP addresses. So instead of, so this is a classical example, classic example, but inside the cloud, if I have to carve out for, let's say, AWS cloud, then I will be able to use only 251 hosts in cloud. So I can have only 251 usable IP addresses, and this is a very common question. This question comes in the solution architect exam and a common interview exam as well, interview question as well. So Amazon reserved 5 IP addresses instead of 2. Okay, what are the remainder of the 3? You can go in there and you can get the detail there. Um, so one is the network address, another is for the VPC router. Third one is the reserved by IP address for the DNS servers, and number 3 is for the future use and the broadcast. Okay, so the last one is for the broadcast, first one is for the network, and then the remainder 3 are, one is for the VPC router, and that is for the DNS, and the third one is for the Amazon future use. So Amazon reserve these 5 IP addresses for you. Okay. So if I go back in here, so here what I see is I cannot have 256 since this VPC is inside the cloud. So I can have only 251 usable IP addresses for my each subnet. Okay. So this is the, so you have a cider block or a big block of ice set aside for VPC. And then from that big block of ice, we created, in this example, we created 2 subnets or maybe 2 bigger chunks out of it. And then the remainder, we just set aside unused, which we can use afterwards. Okay. So, so this is, a common, example for the VPC. Now,
So sorry, could you just show that site from where you found where the 5 IPs are reserved for
yeah,
in
sure.
AWS? How did you find them?
What I did, I just simply searched AWS subnet reserve IP addresses, and it gave me this answer. I can just paste this, Google link in the chat for you guys. And so, and also, this is in the AWS VPC documentation as well. Um,
Thank you.
yeah, sure. Okay. Alrighty. So this is another example architecture. So what we have here is we have 2 availability zones. Okay. And these availability zones, we have, 2 different subnets, and these subnets, so this is AZ1, this is AZ2. They are inside the same VPC boundary, if you see that. And these AZs are within the VPC, and within those AZs, they have created 2 subnets. One is the VPC subnet 1, and that is subnet 3, they call it. And each has its own dotted boundary that has some servers running in here, some servers running in the other one here as well. So if I just put it into perspective for you guys, like as an example, we saw in the dashboard, let's say this is, for example, this is our marketing department, and for example this is our finance department. So marketing has its own servers, and finance has its own servers, and they are running in two different subnets, but they are part of one bigger, bigger boundary or bigger block of ice, where we carved out two subnets. So marketing has its own subnet numbers and whatnot, and then finance has its own as well. And then if and here, if you see that there are the subnet 1, subnet 2, sorry, subnet 3, subnet 2 is here, subnet 4 is here. So what they did is, they carved out those subnets in such a way that they made those, if you see that it says web server, so web server means that it is being exposed to the outside world. This is the internet sign, so it is going to the internet, so it is exposed to the outside world. But if you see that this black boundary here, this is where their databases are sitting in. Let me just expand on it a little bit more. So they preserve the databases, preserve in the sense that they don't want those databases to be exposed to the outside world. So they created a subnet, which is a private subnet that is not routable to the outside world. Like, it is not connected to the net gateway, and it just stays within the boundary, so that nobody from the internet be able to access them. And how it does is, outside, let's say this is marketing's website which is running in here. So let's say if I go in here from the internet, I'm gonna just connect to it, and then come and connect to the web server. And let's say if I have something running, which let's say I have to run some query on the database from the web server, then web server is going to connect to the local, the local subnet, and query the database, and then pull back the data and publish on the web server, instead of me coming in directly into the database, because database is the like data is the is supposed to be the secured commodity within any organization. So we do not expose the databases to the outside world. They have to stay within the the close control. And then we have those layers, and those layers, they come and connect to the database. The layer which is exposed to the outside world, try to keep not having it connect them. That's another example here. Like, there are account boundaries here, so we have one account here and another account here. We have two different VPCs, and these two VPCs, they are connected through the network load balancers, and getting the work done. Okay. All right. Let's go further deep into the VPC. We saw the subnet. Then there is a route table, and the purpose of route table is, you see that each subnet has its own route table in here. So route table defines if the traffic needs to stay within the boundary, or needs to go outside, or needs to go and talk to the other subnet. So the route table that tells, or that defines, this type of traffic flow. That what traffic is gonna flow outside to the internet, what traffic is gonna flow within the two subnets, or what traffic is gonna go, or is going to stay within the subnet, not going outside, but just whatever is sitting within that subnet. Let's say we have like 20 different instances. They will just they want to communicate within each other. So their route table will define that they do not have to go outside. It will just stay within the boundary. So that demarcation line is defined as at the route table. NACL is one layer there, which is actually it's a layer above the security group. Remember, we created the security group. There is another layer of security on top of it, which is NACL, or network ACL. or network access control list. And the purpose of that is to introduce another layer of security. So let's say if your security group is open for the entire world, but NACL, if you put the, security boundary there, so it will not go outside. It will just, stay within that. And then, within it, you see the security group, which we did very extensive lab on that security group. There's another component which is called the internet gateway. The purpose of internet gateway is, let's say my subnet 1 is my web subnet, and let's say my subnet 2 is my data subnet. Okay, in my web subnet, I have these instances, they are running the web servers. And in the database subnet, let's say these are my databases sitting in here. So those subnets that need to go outside and talk to the outside world, say, these web servers, they need to go and talk to the internet, right? So for these web servers, what we do is um, we attach the internet gateway to them. Um, So the purpose of internet gateway is to take that traffic from all these security boundaries to the outside world or to the internet. And this internet gateway, we assign it to, let me just erase that. So this internet gateway, and this is one additional component of the AWS VPC. The internet gateway is whichever the subnet we are going to assign this internet gateway to, that will get the capability to take the traffic to the outside world, means to the internet. Okay, if the subnet gateway, sorry, if the internet gateway is not assigned at all here, then the traffic will stay within the VPC boundary. Traffic will not be able to go outside to the internet. No incoming, no outgoing. Okay, it will stay within the VPC boundary. So all the traffic will be the internal traffic. Okay, and then there is a NAT gateway. Okay, what is the purpose of NAT gateway? Sorry. Purpose of NAT gateway is, let's say I have, let me just go back in here. I'm gonna go back to the netting example here. Come on, I'm sorry. Okay, the purpose of NAT gateway is that these are my, let's say, private subnet machines, and I cannot, and let's say, these are all my web servers, and they need to talk to the outside world. Okay, they need to talk to the internet, but I cannot afford a public IP address. Let's say, my organization is very cheap and I cannot afford that. So what we do is we put a NAT router or NAT gateway here. What it does is it actually translates this. So NAT gateway will have one public IP address, and what it does is there's an internal algorithm running, and there's a deep networking and IP v4 packet translation and all that. So this machine will not be exposed to the outside world, but like this IP address will not be exposed to the outside world, since this is a non-routable internal IP address. So this IP address network, like this machine, is gonna go to the net router or net gateway. This IP address will translate it into this public IP, and then this public IP will make an outbound request. And then, once the outbound request comes in, it comes to the net gateway first. Net gateway translate it back. Hey, you know what? This packet is coming for this machine, and it will send, this traffic back in here. So this way I can have, let's say, one IP address for my net gateway, and I can have, let's say, hundreds and thousands of machines sitting, behind that. And proxy is one example of that, so that, I do not have to purchase IP addresses for all these machines, or like public IP address or routable IP address for all these machines. All I have to do is just, purchase one IP address here, configure my NAT gateway, and then, they will all be able to, be able to, access the outside world.
This is the similar example of cyber cafe, right?
Yes, cyber cafe, yeah. Very common example, yes. I don't know if cyber cafes are still in demand these days or not.
In Pakistan, few of them is still there.
They are still okay. Yeah, yeah. So, so this is how the principle of net gateway works. Okay. There's another component which is called jump box or bastion host. So what it does is, let me just go back to the drawing board. So here, what's happening is, and this is very common, and we normally.
Fascinating question.
Yes, yes.
So the net gateway, it's a kind of a device would be, or it would be the any EC2 machine.
It's a software component. So everything in the cloud is a software component.
Okay.
Yeah. So here, topic here, the jump box or the bastion host. So how it works is, and this is what we deploy pretty much every client, be it on the client on the cloud or in a local on-prem, setup. That this is, one of the additional security layer, we add, with those clients. So how it goes is, say you have your VPC boundary and other components, and then you have your different, let's say, EC2 instances running in here, right? Okay. In this case, let's say if we grant access from the outside world, people be able to connect and do their work. Let's say a developer coming from India and connecting to machine A, or a support person coming from Manila and connecting to this machine. So instead of doing that, giving them direct access to it, so what we normally do is we create a bastion host. So along with the rest of the network security boundaries, this bastion host only will have access from the outside world. So people come and connect to this, and then this bastion host will have access to the rest of the machines in here. So this way, what's going to happen is none of these machines will be exposed to the outside world, and only authorized people who have access to this bastion host. And bastion host is normally a Windows server that has the RDP capability or the PuTTY capability enabled in there. And with that PuTTY, they will be able to connect to, or RDP connect to those Windows instances. So bastion is another layer of security. Yes.
Bastion host is a concept of the IDS, right? Intruder detection machine.
No, not the introduction detection. This is not the IDS or IPS capability. It is mainly to grant you access to the local networks, because these machines, we assign the local non-routable IP addresses, and since they cannot make connection to the outside world, but outside world needs to connect to them, and net gateways at times they are not very commonly used. There are a couple of reasons behind that. One is they cannot handle the load of a bigger footprint of your machines. So normally a bastion host is another layer of security. So let's say if I have to stop the communication in here, all I need to do is just turn off the interface of the bastion host. Now that bastion host is not accepting any connection, that means that the entire infrastructure is just sitting there in a block or in a bubble. So this bastion host, it gives you an added layer of security. And also, we do not want the developers to be running, tools on their machines. Instead, we give them access to it, and then their tools are residing in here, and through these tools they will be able to to connect to whatever the machine they want to connect and perform their work. Okay.
Okay.
Okay. All right. Next one is the elastic load balancers. So there are three different types of ELBs or elastic load balancers. The third one is Amazon is just getting it removed, so it will be gone in coming days. The two major types which are commonly used, one is the application layer load balancer and the one is the network layer load balancer. What is the difference? Application layer load balancer, they work at, if you guys remember, the DOT model, which I talked about, the 7 layers, um, physical data link network, PDNT, SPA. So the layer
OSI.
7, I'm sorry, what?
You said OSI layer, right?
OSI layer, yeah, exactly, yes. So the layer 7 is the application layer, and then layer 1 is the physical layer, right? Physical data link network transport session presentation and application. Okay, so physical layer is layer 1, data link is layer 2, network is layer 3, transport is 4, 5, 6, and 7. Okay, so Amazon's load balancers, they work on 2 different layers. Application load balancer, as the name suggests, it's a layer 7. Layer 7 load balancer, and the network load balancer is layer 3. At times, we call it layer 4 as well, but for the simplicity sake, network load balancers are layer 3 load balancer. They'll work at the, excuse me, they work at the network layer. What is the main purpose of load balancers? The main principle behind the load balancer is, let's say I have, let's say I am Google. I have, let's say, several 100,000 servers running, serving google.com. Okay, so all these servers, if I just expose them to the internet, right, then I will have to expose them all individually, right? And that will require, several 100,000 IP addresses. And this way, what's going to happen is, let's say there's a special coming in, I get connected to, let's say, server 1. Let's say someone else coming in, right? They will also connect to server 1. And people start coming in and connecting, and they will all be connecting to the server number 1, unless people know the IP address of server 2, server 3, or maybe server 200,000, right? So this is not an efficient way of because at one point in time the server will crash, and then let's say google.com is gone, right? So what it does is, how it goes is, instead of this, there is a load balancer. Okay, that load balancer is connected to the internet. So this load balancer has a public IP which is exposed to the outside world, or a domain name, say uh, google.com. Come on, machine. Please cooperate for a couple more minutes. Say google.com is running, so google.com will be running on this load balancer. So whoever is coming from the internet, they are connecting to this load balancer. You and I, or the entire world is connecting to the Google, so they all are connecting to this load balancer, and underneath that load balancer there is a farm of instances running that are running the same web server. Okay, so let's say Google has, let's say, for example, 100,000 web servers. So they all will be connected under the same load balancer. And then the purpose of load balancer, as the name suggests, right? It balances the load across the the servers which are underneath it. Okay, so it does not just simply send all the requests to one server. Otherwise, this server will crash. The purpose of load balancer is to split the load, maybe, and there are certain algorithms that are behind that, and we're going to look into it. Some algorithms, they are round robin. Round robin is, um, let's say it runs in a circle. So it picks one server, the next request comes in, it picks the another server, next request comes in third server, and it got, it just, distributes across those. There are some weighted algorithms, that it looks into, hey, if the load is let's say 50%, it will not put the send any request to the server. It will send the request to the other available servers, or it keeps monitoring that. So there are different algorithms in underneath it, but the overall principle is load balancer. It balances the load among these servers underneath it. Okay, so this is a layer 7 load balancer where the application is running, right? So your web server is running. So that is the layer 7 where the application runs. So if I have to load balancer among the application layer, then I'm going to use the application load balancer. If I have to load balancer on the at the network layer, which is the layer 3, then I'm going to be using the network load balancer. Application load balancers are very common. Okay, network load balancers are common, but they are mostly common, or their common use case is within the network. Let's say if I have certain network components, I want to load balance among those, that's where I use it. But mostly even if you are going to do any job or perform any job, let's say in the cloud space, majority of the time you will be using or creating or supporting application layer load balancers or the application load balancers. Okay. um, so here there is one example. So you see that in this example, let's say the person is coming from the network or from the internet, comes in, and then it gets hit by the the person hits the load balancer. That load balancer will just determine however many web servers are running underneath it, and then get the work done. Then there is, so this is for the external layer, right? So from this person, see if that pen works. Yes. So from this person up to this layer, this is the external connectivity that I am going to connect through the load balancer to the web server. Let's say this is the google.com, right? So what the purpose of this load balancer is to spread the load across these web servers. Then internally there is another load balancer you are seeing. The purpose of this load balancer is, give me 1 second. Sorry about that. All right, so there's another load balancer you are seeing. This is an internal load balancer. What it does is any request coming from those web servers going into the application servers here, So this load balancer balances the load among the application layer. Let's say I have another layer here. I can have, more load balancers here. Let's say I have a very complex infrastructure. There's more, components here. I can have more load balancers, as we proceed along. Give me 1 second. Apologies, guys. All right, so we can have multiple load balancers. Let's say I have very complex infrastructure, and wherever I feel the need to plug in that load balancer, I can, just simply go in and, put it there. Okay. I know we have a couple of minutes left. I want to finish the AWS auto scaling, and then we'll continue on the DNS services in our next class because DNS is going to take longer to finish. All right, so auto scaling. So what is the purpose of auto scaling? And this is one of the key feature of any cloud provider. Actually, this is a key feature of a cloud. And what it does is auto scale. It it is like whenever the demand comes in, it will automatically expand your, let's say, your EC2 instances. And whenever the demand goes down, it will auto descale your infrastructure to save you money and do not get burned down on the billing side. So let's say here in this example, we have a minimum size. Let's say I am running a business where I see a drastic growth or drastic traffic on my website during the Christmas time. And then after the Christmas time, everything goes normal. And then, I have a very steady growth. So um, let's say if this is a graph, let's say this is January, or you know what, let's do one thing. This is my traffic graph, which I'm seeing. So let's say this is June, and this is May time frame, right? So if it's a 12-month graph, what I see here is, let's say this is November, December, January, for example. So what I see is my traffic pattern goes steady, and then it goes start building up in November, and peaks up in in December, and then in January it comes down, and then in May it goes back to the normal one. So during this peak time, let's say my traffic to my website goes, let's say 1,000%. It increases 1,000%, stays up to 1,000% until January, and then it goes back to normal. So for example, I have a one web server which is running on EC2 instances. In EC2 instance, that is serving me well from uh, from June through, let's say from June through November timeframe. I have one web server that is serving me well, and then after January through May as well, one web server works out fine for me. But during the peak time, what I find out, let's say that was like first year of my business, starting November until January, let's say my website crashed, let's say 300 times. And whenever I see, I saw that, whenever the traffic start building up, it just crashes. Let's say, if the website hits are, for example, 20 times what my actual, website traffic is. So once I find out, hey, you know what, this is happening. So I had two options. One is I can, running the business smooth from June through November, and then in November, let's say I increase, from one web server to, let's say, four web servers, and keep running those four web servers, from November through January, and then, manually I shut down those web servers, and then, go back to the normal capacity here. That's one way of doing it. But the elastic nature, the automation, behind that, I can leverage that and do not worry about, my website crashing while I'm, while I'm cruising around the world, and, my business was running fine, and all of a sudden, people start calling me, hey, you know what, your website is not working. We cannot make any, um, we cannot shop anything, from your website. So then I'll have to cancel my vacation and come back on, hey, you know what, let me just go just manually do that. So in order to address this, what auto scaling does is, we define the rule in auto scaling. Let's say if my network traffic goes above 50% on my EC2 instance, let's say this is my EC2 instance, if my network traffic goes above 50% and it stays above 50% for, let's say, 2 minutes, then go ahead and churn out another EC2 instance. Okay, and also monitor that as well. Let's say the traffic does not go below 50% for additional 2 more minutes, churn out another one, and keep an eye out on the network traffic. And once the network traffic goes down, and it goes down to, let's say, 20%, and stays 20% for, let's say, 5 minutes, then start killing one web server at a time. Okay, because I do not want that web server to be staying idle, and keep an eye out on the other web servers as well. If they are uh, you know fitting the same bill, and they are staying 20 minutes for 5 minutes or more, just kill those, and then keep the base capacity there. So this is my minimum capacity that I can run my business, with the minimum capacity. This is my desired capacity. Let's say, if it goes, beyond that, this will, kick in. And then this is the scale out I set up. So let's say I set up for four web servers. My normal business runs fine in, with one web server. Desired is, let's say, if it goes beyond that limit, just churn out one more, and stay within the desired limit. But if the desired limit is hitting that wall as well, then I give leverage to AWS. Hey, you know what, when it goes beyond that, you have the leverage to churn out two more for me. Okay, so I can have four web servers automatically kicked in, and they will handle this, this capacity peak here. Okay, same goes, this is the scaling out. Scaling back in, let's say, we set the rule here, for example, 20% for, let's say, 5 minutes, start killing those. So this is the minimum size. This is the minimum size I have, and this is the minimum size I have, and this is the maximum size I have. And this will all be done once we set those rules. This will all be done automatically. Automatically, it will scale out. Automatically, it will scale back in. Gradually, it will scale back in. So my peak time traffic will always scale out, and then in off-peak time traffic will always scale down. This also helps me out in another use case. Let's say I was running this business, and find out, hey, you know what, this year, let's say last year, because of the pandemic, nobody came to my website. I was running just a smooth straight line, and there was no peak I identified during the peak time. So if I did not I and encounter any peak time, so this auto scaling group is not going to kick in. It will not kick in based on the time. It only kicks in when the set rules are met. Let's say network traffic goes beyond this number, or traffic or application traffic goes beyond this number, then kick in. If that does not kick in, I will not get charged for anything extra because I am not running any additional, additional capacity here. So, during the pandemic time, for example, my business kept on running with one web server for the entire year. So I do not have to, create anything manually to address that capacity. So you do not have to guess the capacity, if the certain rules are met, then new one will churn in. If not, then, it will stay there. Once that new instance is churned in, then I will be charged for that. If not churned in, I will not be charged for it. Okay. Um, Going to the next one, same thing, auto scaling group, and then auto scaling group actually it connects with your just close it here, clean it here. So auto scaling group, they work hand in hand with elastic load balancers here. So once we set the auto scaling policy for our web servers, the elastic load balancer, since it works hand in hand with auto scaling group, it will get to know automatically that if there's a new server comes in here, then it will add, instead of one two server, it will add the third server into its list to balance the load between among these three. If the fourth one is added, this will have this will get to know right away, and it will start distributing the load among those. Once those servers are down or closed out or terminated, this EC2, sorry, this load balancer will remove these from the list as well, and it will just distribute the load among those available ones. It has an heartbeat process running. It goes and checks the heartbeat as well. If that server is running fine, let's say that server, let's say I have like 25 servers running, out of which 5 servers, they for some reason they get crashed. So it will get the load balancer ELB will get the health check results after certain intervals from those from all the servers. So whoever is not responding back to it, it will mark them as unhealthy, and it will not balance the traffic to these unhealthy ones. It will just balance the traffic on the healthy ones only. Okay. All right, so I'm gonna stop it here. I'm gonna stop recording, and for any